In this video, we will learn about tangents to a circle. Let us see what is a tangent. I have drawn a circle and a radius also. Radius is depicted by the dotted line, and there is a solid line which is touching the circle at one point only, and that point is known as point of tangency or point of contact. So what is a tangent to the circle? Tangent to the circle is a line. It's not a line segment. It is a line which is touching the circle at one point only. And at that point, if we draw the radius to this circle, then that radius is always perpendicular to the circle. This we are going to prove on later. Now what is a secant? A secant is a straight line that cuts the circle at two distinct points. If the line is cutting the circle at two distinct points, then it is called secant, and if it is touching the circle at one point only, then it is called tangent. Now if we wish to draw tangents to a circle, then you may think that there are infinite tangents because there are infinite points which can be there on a circle. Now let us see which two theorems we are supposed to prove here. One is radius is always perpendicular to the tangent. That means it is shown in the figure 1, the radius and the tangent. The angle between them at the point of contact or at the point of tangency is 90. And second is that two tangents drawn from the external point to the circle are equal in length. One is that whenever we are outside the circle, we can draw only two tangents. And if we are on the circle, like in the first figure, I can draw one tangent only. And you cannot draw any tangent to the circle if your point lies inside the circle. Now see the figure 2. There are two tangents which are depicted by pink line, and the radius is depicted by blue line. And I have joined the point of intersection of tangents to the center of the circle. So what we'll prove here is that these two pink lines, that means the two tangents to the circle, are equal in length. So these two theorems we are going to prove later. Now see this one. OA is perpendicular to AB. This is what we have to prove. So this is the first theorem which says that radius is perpendicular to the tangent. So what is given to us in this theorem? Given is that AB is a tangent to the circle. या इस पूरी लाइन को हम एक और नाम दे सकते हैं small l, which is tangent to the circle. And what are we supposed to prove? That OA is perpendicular to AB. So you will write to prove me OA is perpendicular to AB. Now what I have drawn is construct OB. B is any point on the tangent and C is any point where this line is cutting the circle. Now I have written something. OA is equal to OC because it is the radius of the circle, and OB is equal to OC plus CB. तो OB तो OC से बड़ा ही होगा because OB का part है OC. So OC being radius and B is any point on the tangent, you know in the figure also that OB is greater than OC. Now that also shows that OB is greater than OA or OA is less than OB because OA भी radius है, OC भी radius है, तो अगर OC छोटा है OB से तो OA भी छोटा होगा OB से. Now B is any arbitrary point. आप कहीं पे भी ऐसे ही ड्रॉ कर सकते हो जैसे मैंने ड्रॉ किया. If you draw in left, if you change the position of B, it does not matter. You will always get OB is greater than OA unless your B coincides with A, और वो हमें करना नहीं है. So what are we trying to show? We are trying to show that this OA is always smaller than OB. And by the theorem in grade 9, shortest distance is the perpendicular distance from that line. So what have we proved here? This is very theoretical proof and you have to write in the language. And what is the language? The language is shortest distance of a point from a line is the perpendicular distance. So I have proved here that OA is always less than OB, where B is any arbitrary point on the tangent to the circle. And hence you can say that radius is always perpendicular to the tangent. Now let us see the next proof. Here you are given a circle with center O. P and PB are the two tangents to the circle which are drawn from an external point P. I have already told you that through external point you can draw two tangents only. And now you are supposed to prove that these two tangents are equal in length. And construction is you are joining OA, OP and OB. This proof is very simple. You can clearly see the two triangles PAO and PBO. Now you have to think how will you prove the congruency of these two triangles. You can see that OP और OP common है दोनों triangles में. OA and OB are equal because they are radii of the same circle. Now can you think of the third reason? Yes, the third reason is OA is perpendicular to PA because radius is perpendicular to the tangent to the circle, and therefore these two triangles are congruent by RHS criteria. I hope it is clear that OP is common, OA being equal to OB as they are radii of the same circle, and then angle A will be equal to 90 degree, equal to B equal to 90 degree. The reason is radius is perpendicular to tangent, and hence I am able to prove that these two triangles are congruent, and therefore PA is equal to PB. Hence I can say that tangents drawn from an external point are equal in length.